Hello everyone. In this video, we're going to talk about lesson 7, confidence intervals for proportions. Okay, confidence intervals for P, the population proportion, to be more exact. Okay, we're going to build off of what we learned in lesson 6 using sampling distributions to make what are called confidence intervals, which are very popular in all of statistics and all of almost every field out there. Okay. And so these will be very important, and this is likely what you'll see the most of in the real world. So there are some connections to be made between what we did in lesson 6 and what we're going to do. So the sampling distributions we learned about in lesson 6 can help us answer questions about the population, because keep in mind that's what we're really interested in doing. We're interested in making some statement about the population given the sample. And so what we need, so for instance, I might be interested if I am a pollster who is working for Joe Biden. I would like to know, or Donald Trump or whoever, I would like to know how much of America supports that candidate. That's very valuable information. Okay, and so that's what I would trying to be get at, if I were them, and I'd of course take a sample because I can't poll everyone and hope that the connection from the sample to the population is not too weird. Okay, hopefully my sample represents the population well and I can get a good estimate there. All right, so enough for the aside. We need other tools other than the sampling distribution to help us answer the questions that I posed at the beginning of lesson 6. Okay, the two tools that we need are called confidence intervals and hypothesis tests. So in lesson 7, we'll talk about a confidence interval. In lesson 8, we'll talk about a hypothesis test. And specifically, we'll talk about confidence intervals and hypothesis tests for P, the population proportion. We'll talk about those for X bar or mu in later lessons. Okay, so confidence intervals try to estimate a value of interest about the population. Okay, so I might ask, what's the proportion of people who support Joe Biden in the upcoming general election? Okay, and a confidence interval is going to be a range of possible numbers that hopefully contain that truth. So I'm going to say, well, I believe that around 58 to 62% of people support Joe Biden. That's a confidence interval. Okay? A hypothesis test makes a decision between two statements about a value of interest about the population. And so I put there court of law. We'll talk about that plenty in lesson 8. Okay? But we're going to focus on confidence intervals here. So when we talk about confidence intervals essentially try to get at a question called estimation, or a part of statistics that's called estimation. So we're often interested in finding some characteristic about the population. We're going to call that characteristic a parameter. Okay? It is a value or a characteristic about the population that's true and that's fixed. So at any time there is a true, if you could go and look into the heart of hearts of people and see who they support in the election and then gather all that information and put it together, the proportion of all people who think a certain way is a parameter. It's a true value about the population. Okay, so for example, so here are some examples. Here are some examples that I want you to think about, and I'm going to try to connect these with confidence intervals. So these are type of questions that you might ask, or you might be asked, and want to try to estimate. So first is a question I might ask is, what are the average number of French fries in a large order of fries at McDonald's? So there's some true number of average French fries out there. Okay, this is actually a means question, not a proportions question, but still good enough for us. There's some true number out there, but of course, every time that you get an order of French fries, if you go to McDonald's, if not, that's fine, just make believe that you do. Every time that you go and you count the number of fries that you get, they're not going to be the same, most assuredly. But in the population of all potential orders of fries from McDonald's, there is a mean number. I want to try to get at that mean number. Okay? They give nutrition values on each of these orders, and there's a nutrition value for a large order of fries based on a certain number of them. Okay, and certainly that's a single number that they used. It's what I want to estimate. Okay. And another question I might ask is, what's the average student housing price for Shippensburg students? Okay, so certainly there is, for all students, they pay something for housing, whether it's on campus, off campus, anywhere else, okay, unless they don't pay anything. They live at home, which is a great thing to be able to do. There is an average out there, but of course I don't know it because I can't talk to all Shippensburg students, and so I'm going to try to estimate it. Now, if I asked you these questions just offhand, okay, would you give me, you can think about this, would you give me a single number or a range of numbers? So, and that's my dog, sorry about him. He'll bark from time to time. So, sorry. If you think about these two questions, and I ask you off the cuff, you may give me a single number, okay? But some of you might give me a single number, but also some of you also might give me a range of numbers. And generally, a range of numbers is probably going to be more helpful to you, okay? And so if I came and I was a transfer student, and I asked about the student housing prices in Shippensburg, you're probably not going to tell me that the average student housing price is $6,792.37 per year. Okay, that's awfully specific. You're probably going to tell me, well, it costs probably between $6,000 and $8,000. Okay, so you're going to give me a range of numbers. And the same thing with French fries, because you inherently know probably that you aren't getting the same amount every time. And so if I asked you about how many fries are you going to get in a large order, you're going to say, well, maybe probably between 110 and 130 or something. Okay? You probably wouldn't say that, but if you were some sort of math nerd, maybe that's what you'd say. Okay. So here is some terminology. Those previous examples were trying to get at the idea behind a confidence interval. In a confidence interval, we're going to give a range of possible numbers that hopefully contain the truth that we're trying to seek. Okay? And so here's some terminology that I'm going to use throughout this lesson. The first is a point estimate. Okay? A point estimate is a single number that is sort of our best guess. If I made you give me a single number, this would be the number that you'd give. Okay? A single number that's the best guess for the population parameter, that true value that we want to know. Okay? And then an interval estimate is an interval of numbers that's believed to contain, sorry, I doubled up there, believed to, and then take away one of the believed to's, contain the actual value of the parameter. Okay, so you can give me a point estimate or an interval estimate. And so here's a visualization of what that might be. So if I asked you for a single number, you might give me 0.73, but an interval estimate, you might give me, well, I believe it's between 0.71 and 0.75. Okay. Generally, an interval estimate is better because it indicates some type of precision by giving an interval of numbers around a point estimate. Point estimates are good, okay, but it's very likely that you'll be off. Okay. So if I asked you what's the average winning time of a half marathon, and you told me, well, the average winning time of a half marathon, unless you knew all of the numbers, if you said 2 hours, well, actually that's too slow. Probably like an hour and a half. Okay, if you said an hour and a half, you would most likely be wrong, because it might be close to an hour and a half, but it might be an hour and 28 minutes and 30 seconds. Okay, and so essentially, if you said an hour and a half, you would be incorrect. Okay, because it wasn't an hour and a half, it was an hour and 28 minutes and 32 seconds. But if you gave me an interval of possible numbers, okay, that create, that hopefully contain it, an hour and 20 minutes to an hour and 40 minutes, okay, it is less powerful than fully right or fully wrong, okay, but it still gives you an idea of the truth more than you knew beforehand. Okay? If you knew nothing about half marathons, you could have believed it was 2 hours, 2.5 hours. Okay? But if I give you an interval of an hour and 20 or an hour and 40, that gives you a range of possible values that could contain the truth. Okay? So we're going to focus on confidence intervals, but there are in fact other types of intervals. One is called a prediction interval, but we won't talk about that at all. But I wanted to let you know that there are others out there. Okay. And so for the rest of this lesson, we'll focus on confidence intervals, and specifically ones for P. Right? A confidence interval is made up of two parts. The first is a point estimate. So even though I don't use a point estimate by itself, it does go into my calculation of an interval estimate. I have to start with my best guess, okay? My best guess about a point, okay? A point estimate, and then I have to add what many people have heard of before. So this term is very popular: margin of error. Okay, so I have a point estimate and a margin of error. The margin of error is a measure of how accurate the point estimate will be at estimating the parameter. Okay, it's made up of, we'll find two parts. Okay, a margin of error is actually two things multiplied together for us. But the margin of error is that sort of level of uncertainty that we know that random things are variable. And we've talked about that a lot, especially in the last section. Okay, that things are going to vary from sample to sample, from time to time that we do something. Okay, if we flip a coin 10 times, it's unlikely that we'll get the same outcome twice next to each other, and certainly they are different all the time. And so the margin of error is how we account for that. And so we start with a point estimate, we start with a single number, and then we sort of stretch that out into an interval numbers, and how much we stretch it out is the margin of error. Okay. And so we start to have this general form of a confidence interval. And so when I mean a confidence interval, or how we're going to represent a confidence interval, is by the endpoints. Okay. So if it stretches from 0.71 to 0.75, how I'm going to show you that interval, or how I'm going to communicate that interval, is using the endpoints, the 0.71 and 0.75. Okay, and so how I get those is I take my best guess, my point estimate, and then I add and subtract the margin of error. Okay, so that stretches out my point estimate into a range of possible values. So to get a reading on this, to get some more information, I suggest reading pages 335 to 340. That'll give you more of a grounding in this idea of a confidence interval in general. Okay, so next time when we come back, we'll talk more specifically about confidence intervals.